Welcome to the All Things DER podcast, brought to you by AEIC. In this podcast, we dig in, define, and discuss where the new energy economy is heading with electric industry leaders and explore all the ways that distributed energy resources can modernize and improve our ever-evolving power grid. Thank you for joining us.
Hi, I'm Dr. Elizabeth Cook, the host of All Things DER. In today's episode, I'm talking with Delvin Stephens, the project manager of DER implementation at Con Edison. We discussed the importance of ensuring reliability with the introduction of new DER and how to create impactful change across the industry by being a lifelong learner, as well as ways to get various industries involved in creating a greener energy future. From the use of secondary grids to decentralization of the grid, we dig into a variety of ways to troubleshoot the rapid-paced challenges that face the power industry in successfully implementing new technologies and emerging DER.
Hi, Delvin. So excited to have you on the podcast today. Let's just jump right in and introduce yourself to our audience.
Hi, and thanks for having me on. I'm Del Stephens. I'm the project manager of DER implementation here at Con Edison. At Con Edison, we have a service area, roughly 604 square miles. We serve about 3.4 million customers, which equates to 10 million people. What's interesting is 87% of our system is underground and only 13% is overhead. So what does that mean? Well, roughly 133,000 miles of our transmission and distribution cable, 96,000 miles are underground. So really unique topology. Interesting fact, we have electric, gas, and steam products. And so we serve about 500,000 businesses and 900,000 residential buildings.
Fascinating. I have to say, out of all utilities, Con Ed is very unique in the statistics, especially coming from talking to other utilities, the rural, expansive ones versus the highly condensed urban areas. So you have your own challenges just to do fundamental grid operations. And now comes the word that we're all waiting for, is distributed energy resources, which is all things DER here at AEIC's podcast. And I met you through Unite, and it has been a great experience. And I would love for you to share, how did you get into the DER space?
Okay, interesting question. Yeah, so I started out as a design engineer for Con Ed, and then I moved up into a design engineering supervisor. Around 2010 or so, there was a job that came across my desk, and it was someone who wanted to install solar panels on someone's roof and not have a connection to the meter panel, but instead have a separate meter specifically for the roof. And so when that job came across my desk, I was trying to figure out, how will we analyze this, right? What is the actual scheme to make this happen? And that's when I realized that my education is starting to become useless and I need to go back to school to understand. How will distributed energy resources affect the grid? And so I ended up going back to grad school, and I got a master's degree in energy management. So now I understand how to make that happen. But this is really what impelled me to get into the DER space. That's my story.
So just one customer wanting to do something very unique within your space, triggered lifelong learning, which is just exciting. I'm a lifelong learner. And what year was that?
That was around 2010, I think.
2010. So here we are in 2022. And I the last episode was Southern Cal Edison. They are actually decommissioning one of their first energy storage systems. And here we over here on the East Coast, as we've been observing for the last 12 years, are embarking on some similar projects. So interesting dynamic that we are in this industry. So I already heard of one of your challenges is becoming technically acute into these challenges. What are some other challenges that the DER interconnection kind of unfolded to you over the last decade?
Yeah, great question. When I think about DER interconnection here in New York City, for the most part, we can handle a DER's exports, right? So it's the concept of that two-way flow that I think all utilities have a challenge with. But with two-way flow, I think there's a new concept called two-way reliability. How do you ensure that a grid asset that has the capabilities to export onto your grid, but you don't actually have control over, participates in a way that keeps the grid reliable? So if you think about the world of the future where we have active two-way power flow, you need to ensure that the power is flowing two ways and that it's reliable. So that's what kind of keeps me up at night, right? And the second is the lack of inertia, right? As we start to lose the fossil fuel based generation, how do we take the power electronics that will be on our grid and ensure that they provide the same level of reliability that the grid edge assets do? Or how do we ensure that these assets provide the same level of reliability?
And would you say that's a question that is still being determined across the industry, not even Con Ed? So it's something that we all do, some of us stay up at night thinking about. We're kindred spirits in that way. I think one thing to share about Con Ed, and really, Duquesne Light also has a secondary network. So when we think about actually I had my sister-in-law ask this question, what is the grid? Everyone's talking about the grid. And we have to remember it's one of the largest machines, multiple largest machines that we've developed over the last 100 years. Well, you have your generation sources, the bulk, then you have your transmission, your distribution, and your customer. And each one of our utilities that we own and operate and maintain have very dynamic designs to begin with. And so even when you think about the phenomena that need to be studied, you can break apart the power grid in 4 components: generation, transmission, distribution, customer. And I think one unique aspect of our grids, being that yours is much larger in size, the underground network is tied on the secondary, so you have this mesh network per se. And so what I heard you say is that Con Ed does have the capability to allow distributed generation to be connected on that grid, or am I thinking wrong?
Yeah, one of the things that we've worked on was how to differentiate the backfeed, exactly as you described, Elizabeth. The secondary grid is designed to have power go one way. So from the distribution secondary into the customer, and then any backfeed would be prohibited. Well, now with the two-way power flow, we've figured out how to distinguish backfeed from a DER source, which is allowed, versus a backfeed due to some sort of misoperation. And having that capability has allowed us to allow DERs onto our secondary grid.
It's very good to know for all of us utilities maintaining a secondary network. So thinking about, your expertise, and you've been sitting in this world, and how, there is ever more happening, emerging technologies, green tech, as some people like to call it. For those that are interested in really kind of being the change and embracing our energy use and sustainability as a whole, you could say, what advice would you give someone who's interested in getting into this green tech world?
Great question. If you think about the world of 2030, some estimate that the economy will be around $160 trillion. And if you think about the 2030 clean power goals, the majority of that will be focused on clean tech. So clean tech is something that I advocate everyone get involved in. Now, do you have to go to college and get a degree and get a PhD like yourself, Elizabeth? Well, you can, right? But there are other options as well, right? There's a whole segment on the policy piece, right? So if you're into policy and looking to change how policy affects us, right? There's a whole aspect associated with that. And then there's the engineering aspect, but also on the software side, right? So if I'm a coder, there's going to be a big need for folks who can code and able to understand how to add that reliability to software systems that will monitor and control the grid assets. So there's several ways to get involved in the green tech space. Room for everyone.
So ultimately, if you find yourself wanting to be a change, embrace this new energy economy, be it the policy, the regulatory, the technical, economics, financial, and really, I believe, the bedrock of our future power grid. It was the manpower, the assets that were installed 100 years ago that kind of control the grid. But as we're moving into this future, it's the neurons, it's the communications, the network, the architecture, and then the brains, which is like IT, heavy. So there definitely is room for all of us to really take part in this transformation that we're in. I couldn't agree more. So kind of getting more technical, which I think we actually kind of did, but what do you see as really this, because you mentioned it earlier, this solution of this inertia, is, being that you're in that area, do you have any ideas or maybe prophesize like what we could do to kind of ensure that this is going to help?
What I think about is in the world without spinning reserves, these power electronic devices are going to have to be wicked fast to make a decision and to change these grid edge assets to add the reliability to the grid, right? So if you think about that spinning turbine, that though it stopped, it still keeps spinning and it's helping to keep the frequency stable. Now, when those assets leave, we now need an alternative. And I personally think that alternative is high-speed internet circuits coupled with the equipment to make these decisions at the edge, right? So if you can think of the world where a decision is being made at the edge, it enacts some sort of change with these grid edge assets that are adding reliability to the grid. And then it's simply relaying what happened back to some centralized control center. And now the control center after the fact can see, okay, is this what we wanted, or should we override what the grid edge intelligence did to keep the grid stable? So I can see a world where we have this really high-tech interactive grid that's thinking constantly about the best way to add reliability, and second, understanding what DER assets are on the edge and what are the capabilities.
So it's really next level, because if you think about how our grid operates now for our listeners, you have, over the last 100 years, we've designed a transmission grid to connect to bulk generation plants all across our rural areas and nearby waterways. And we built transmission to then drop down into distribution to serve our customers. And then ultimately those electrons went into the homes and were consumed by our customers. And so from that inertia perspective, what we've created is a machine that every large generator is spinning 60 times in 1 second. So that's the frequency that it must. And there's this massive inertia. And so that's a centralized grid. So we had bulk generation with a cobweb of transmission serving pockets of our customers. And what you're kind of talking about is decentralizing. So we're really breaking down the smaller distribution grid to enable this fast, what you call it, wicked fast response of this new generation that's smaller, but a lot of. So we're going from this few to few model to many, which is this data optimization, machine learning playground. So, right. and we've seen in other industries that this is plausible. It's just that I think the electric utility space, because of our regulatory and policy framework of each grid, has really limited us to really expand ourselves into this world of innovation and embracing new technologies. And I think that's coming. And you kind of pointed that out. You took us to the next level there, Del.
Thanks, Elizabeth. Yeah. You know what I'm thinking? You mentioned frequency, and I think that's one of the key pieces there. Here in North America, we keep it at 60 cycles per second, but as that starts to shift, it causes instability on the grid. And these spinning turbines, they allow the grid to ride through these disturbances. So as you lose these fossil fuel-based spinning turbines, you have to replace them with the devices that can maintain the rate of change of the frequency, and that, or what some folks call rock off. If you can actively understand and then control the rate of change of frequency, you can get two-way reliability that's essential for the green tech grid of the future.
And I think what's, just from this conversation, and one of the purposes of the podcast is really to get inside the utility space and hear our voices, that these challenges are arriving at a very rapid pace, right? We went from an industry that built out a grid to serve the have and have nots at the turn of the century. And I love this story. So sorry, listeners, to hear it again. But it wasn't until the 1930s when we had the New Deal where we decided to electrify rural America. And that empowered the utility space to really take our assets into areas of less consumption. Because, based on utilities being owned, not privately per se, we were in a regulatory environment where we got to be the monopoly while our state or our commissioners set our rates. And that started in 1911. But ultimately now we built it big, more, better, and then tapped out around the 70s on serving our customers. Like, everyone now used the adequate amount of energy. And then we started talking about energy efficiency, reducing energy. And so we're in this space now where not only are we coming out of a place where we were building business models to actually drive our customers to use less of what we sell, but now there's an ever increasing matter of fact that electrification is happening, not only in our homes and our buildings, but our vehicles. Now we have to set up those systems that we kind of are talking about, the OT, IT systems, to enable the communication and then the manageability, be it the utility space or a third party, to understand what is happening at each and every home, to be able to incorporate the full benefits of all of this new technology. And we've listed a lot of it, but it's really enabling that two-way flow, moving load, aka transportation and vehicles. And the homes we're seeing the work being done that retrofitting and new homes are more efficient, and operationally we're showing less to be electrified. So we're now looking at this extreme load increase that we need to think about. So I guess throwing that back at you, in this carbonless generated world that we all are talking about very heavily these days, how do you see millions of these devices being scaled in the systems that we have today? I mean, do you believe that technology and capabilities out there?
Yeah. If you go back to some of the basics, right, of just human nature, why do we do anything? And if you start to look at just human nature, at some point we have to understand, how do we incentivize someone to take an action, right? What is the value of a green energy action? And as you start to break it down to its most fundamental element, you start to recognize that in order for us to be successful in the US and North America, in the globe, with going carbonless, we have to make sure everyone has an opportunity to participate, right? That we're creating value streams for all segments. You mentioned how in the 1930s, the electricity wasn't really available for everyone. There was a have and have nots, and then they pivoted away from that. We have to ensure that as we go carbonless, we don't have the same element.
Yes.
There's a segment, like in some certain cases, low to moderate income households who get left behind. So in order to scale, first, I think fundamentally we have to solve that, right? What are the incentives? What is the essential value that everyone can bring, and then understand that, and then second is bringing systems that can unlock that value. So, for example, in certain segments here in Con Ed territory, there's buildings and apartments, so you won't have as much rooftop solar, right? But there are technologies that folks like myself who live in an apartment can gain, and that can help the grid, right? So how do we ensure that folks who are living in, say, an urban area can have their specific design scheme that'll help out the grid, and then those in suburban areas can have their specific design schemes? And then I think lastly, the enabling tech has to be distributed, right? So If you think of the intelligence to actually schedule a building or schedule a neighborhood or schedule a borough, you have to have the IT and OT systems that can actually have that containerized instance of distributed intelligence at the grid, right? So that I have some machine somewhere local in the neighborhood that understands what everybody's capable of doing, is understanding real time what's happening on the grid, and make a decision that's equitable for everyone. So this is a real interesting use case that you and I and other folks in the utilities are trying to solve, because not only is it just like a technical problem, but there's also social economic problems that are involved, and the confluence of that is what I love about this space.
Yes, it's very exciting. I think you and I are another ones that could talk for a really long time. I just want to say that what I heard there is that you do see, and you're a visionary, a thought leader, that the technology and the capability is, especially in a very tightly meshed New York of New York, that you see the vision and the path forward to really incorporate all these devices and be able to take action on this new dynamic. So I'm glad to hear that. And I want to thank you for sharing your knowledge, and I look forward to our continued collaboration together.
Thanks for having me.
That's a wrap for this week's episode of All Things DER. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.